Now, this lesson talks about arithmetic operators and floating point numbers. You're already familiar with plus, or add, subtract, multiply, which is a star. They don't use the X for multiply. They use a star, and divide. So you're already familiar with those four types of arithmetic operations. For example, you can, just like we've done before, you can assign a value to hour. You could actually put an arithmetic operation or expression in a println statement. So this should print out however many hours it is, multiplied by 60. So I printed out the converted value to minutes in this case. An interesting thing you have to keep in mind, division will truncate the decimal part. If you're dealing with an integer, as far as Java knows, an integer has no decimal places. It only has the number before the decimal. So if I do 90 minutes divided by 60, I should get 1.5. So you would expect it to round it up to 2 because that's how we normally do rounding. Java doesn't do that. It just chops off or truncates the decimal part. So my answer is 1 in this case. You've got to be really careful when you're doing division with integers. In fact, whenever you're doing division, it's probably best to use what's called a floating point number. The way you declare it is by using the keyword double. Floating point just means there's going to be a decimal point in it, and the decimal point could float in the sense that sometimes there could be 5 numbers on the left side of the decimal and 10 on the right, or sometimes there's only 1, like in pi, 1 before the decimal, 2 after. So that's why it's called floating point, but it's really meant to use anything that has to do with decimal numbers, and it's called a double again. So in this case, what happens is if I declare minutes as a double, look, I give it a value with a decimal point. I could give it a value without a decimal point. Java would automatically convert that for you, as we did down here. But it's really not a good practice because you really want to keep in mind what the types are. And even though this would work and Java would convert it, you might end up getting some kind of error later that you didn't expect. So anyway, in this case, this is a double. So when it does division now in Java, it's going to do decimal division, and it will retain the numbers after the decimal, the numbers to the right of decimal, so I get the right result, 1.5 hours. This one won't work because pi is not an integer. There's no such thing as 3.14 being an integer, so it'll complain. This one, as I already talked about this, it'll convert it for you, not a good practice. This is also legal. It's not going to kick it out or anything. It'll let you do it, but the problem is when you do this division, look, you're doing integer division. Those aren't floating point numbers. Those aren't decimal numbers. They're just integers. So 1 divided by 3 in decimal, when you're doing decimal division, remember it'll get its result. The result would be 0.333. But remember, it chops off everything to the right of the decimal. So your answer is actually going to be 0 in this case. So anytime you're doing division, don't use integers. Okay, there's also something you have to keep in mind. Rounding errors, they're not really errors, but it's sometimes it has to do with how numbers are represented internally in Java. So 1/3, even in math, 1/3 as a decimal is not really exact. These 3's go on forever. So it's represented as a number that's not exact. So sometimes you get errors because of that. If you try to do something like this, add a 0.1 10 times, I should get an answer 1, but actually the result is 0.999, 16 nines, because of the way this is internally represented in Java. So a lot of times you can run into errors like that without even realizing it, rounding errors, so you have to be very careful. Okay, this one works because here you're doing an integer. Integer numbers, they give correct precision, so it's not an estimate. Now let's take a look at some of these integer division and double problems that you could potentially have. Okay, so the first thing I do, I have integer, hour and minute. You can declare 2 variables on one line separated by a comma. None of these are initialized, so I have to make sure I initialize them, which I do in the next 2 statements. Okay, there's also another hour and another minute, different types of variables that I've defined. So what this should do is you print out the current time being 11:59, and it's going to try to calculate the number of minutes since midnight, but let's see what happens here. So I'm taking hour, converting it to minutes because I multiply by 60. That's how many minutes are in the hour part of this, plus I add on any remaining minutes. I should get the number of hours since midnight, and that should be correct because it's all integer. But what happens when I try to do a division of integers? Remember, it's going to truncate, so I'll probably get a 0 here. What I do here is to try to get around that. if you're thinking of it as percentage, all they did here was multiply by 100, which means basically I won't lose 2 decimal places if it drops them because I'm dealing with a bigger number. So let's see what happens when we run this. Okay, so it did just like I expected. Let's see if I can print this out. Okay, so the current time 11:59, number of minutes 7:19. Remember we said the fraction of the hour that has passed will be incorrect because it's going to truncate anything that's after the decimal. So it wasn't even 1 hour, it was just slightly less than 1 hour. So it truncates it to 0. If I deal with it as percent, I basically don't lose 2 decimal places because I move the decimal place over to the left twice by doing this. I'm sorry, to the right. So this is correct. So this gives me 98% of the hour has passed, or 0.98 of the hour. So now let's look at some of this integer to decimal division errors and conversion problems we could potentially have. We're defining double pi, so it's a floating point, which it should be. When I assign it, it shouldn't complain, and when I print it out, it should print it out correctly. So let's see what happens. Okay, so it did print out what I expected. If I do this, if I change pi to an int, which it isn't, whoops. If I try to run it now, it won't even let me run it. There's a type mismatch. It won't let me do the conversion in that direction. It'll let you do it in the other direction if you're putting an int into a double, but again, that's not the best practice if you can avoid it. So it's complaining at line 16, which is exactly there. So let's get rid of this now. So let's see what happens if I try to turn y into 1 divided by 3. Remember, I expect it to be a fraction or a decimal, so I'm using doubles. I'm using using decimal numbers. So when I run it, it runs correctly. I get the correct output. That's the decimal representation of 1/3. But what happens when I try to make this into an int? Remember, it may let me do it because I can do 1 divided by 3. When it assigns it to the value y, which is an integer, remember what's going to happen. Well, actually, it's not even letting me do it here because it's a whole problem because I'm trying to do decimal and assigning it to an int. It'll let you do it the other direction, but it won't let you do it this direction because it knows you're very likely to be losing something. So instead, what if I do this? Let's turn these into integers. Now it should let me because here's an integer, I'm doing integer division and I'm assigning it to an integer, so it should let me and everything should be fine. But what happens, I get the value 0. Remember, it truncates. If it's an integer, instead of rounding wherever it should be, it truncates everything to the right of the decimal place, so all I'm left with is 0. It should have been 0.3333 and so on. I got just plain old 0. Okay, now remember we talked about this. If I have 0.1, which is just represented as 0.1, or close enough to 0.1, multiply it by 10, I should get the correct output. Remember we said 0.1 it's just an approximation when it's represented internally, so when I add it together 10 times, that approximation, the little bit of error in my approximation adds up, and it does turn out to, it shows up what the error is. So this is the case where I'll get the 0.999. I'm just going to run it to show you what I mean. Okay, so again, I have this, I multiply by 10, everything's fine. I moved because all I'm really doing is moving a decimal place. But this one, every time I do the addition, every single time I do the addition, the error, the internal representation that of this value, which is not exact, the error gets accumulated each time. So after 10 accumulations of that error, I end up with the wrong answer, which is very close to 1.0, but it's still not what I wanted. And just as a last example, I want to show you what the compiler error is when I try to have something that's not a variable on the left-hand side. Remember, a variable always has to be on the left-hand side. So statement number 13, hour equals minute plus 1 is correct. The variable or the storage location is on the right side. I'm sorry, the left side, and that's where it should be. The expression is on the right side. In this case, this is not a storage location. This is an expression. So this should give me a compiler error, and let's see what happens when we run it. Yeah, we get all kinds of problems at line 14, and it's all because I have this flipped. I meant to have hour on this side and minute plus 1 on this side.